Hello everyone and welcome to part 3 of our open mock paper review. We will be going over question 14 to 19. This section is entitled Rigorous Non-Rigor because you would not really be able to prove everything here in 100% of a rigorous manner. It is round 1. However, you should try to use rigorous logic and sort of say that, well, I would be able to write a proof for this if I needed to, if I had sufficient time, which in round 1 I do not. Now, apologies for typos. Obviously, the actual SMO, on one hand, they have a committee, on the other hand, they also do make typos. But that happened on a couple of occasions, as you can see. And so this one here, this is supposed to be BD in place of BC. But I assume that hopefully you understood what that meant. Because when I said define it similarly, I would not be able to define it similarly if it was just using the points in a random way. So your lines are defined to go through a midpoint of two of them and perpendicular to the other two. But this is supposed to be symmetrically defined, and therefore the first condition in a way is that PQRS should be equal by symmetry. Because the fact that I tell you there's such a point, if you swap A and B and P and Q, it should still work, but P and Q should not be different. Otherwise, you would have more than one answer, right? So your lines can only go through one common point. Therefore, you can assume this. And therefore, I can just pick one special case. To figure out what PQRS are, I will just pick a very simple example. Like let's say, if I were to draw a circle with AB as a diameter and C and D being, let's say, just repeated points. In which case, A, B, C, D would sum up as vectors to something down here. Right? This is A plus B plus C plus D. And I can pick one of these, not line AB, because that doesn't really do very much. I can pick line AC because that is actually going to be well understood. All right, this is your midpoint of AC. This is supposed to be perpendicular to BD, which means that your line AC is this line itself. And because it's supposed to go through, now PQRS are equal, so it's some multiple of A plus B plus C plus D. It is supposed to go through something on this line, which is the point itself here, which is half A plus B plus C plus D. And therefore, it just tells you that P equals to Q equals to R equals to S equals to 1/2, and you get an answer which is 5. Now this is how you get the answer, or at least one of many equivalent ways to get the answer easily. And if you are then trying to check why does this actually work, because didn't you say that C and D are distinct? Yeah, I mean you can take C and D to essentially be just 1 micrometer apart. That's not the important thing. The important thing is that if I wanted to explain it, I can. And here's how. Now, assuming that, let's say, I solve it in general, line AB, it must pass through A plus B over 2, which I'll just say is half A plus B. And it must be perpendicular to, let's say, the CD. Now, we have a direction, let's say V satisfies V dot C minus D equals to 0. This is what the perpendicular means. Now, we can note that to use the unit circle condition, I usually want to get the magnitude. And if we note that C plus D dot C minus D will be equal to 0, that means that V is in the direction C plus D. Which clearly shows that it will pass through half A plus B plus C plus D. Now this is the explanation. This is not what you are likely to think of in the time frame of an SMO. With apologies for the typo, I think it is just an illustration of the difference between solving it as a student participant and reading what the teacher / question setter has to say in an SMO book or even in my videos. So I want to make this very clear, and this is going to recur. Question 15. Now, the answer to this is perhaps easy to guess and yet hard to guess. So I do not mean that you're going to guess randomly. When I said rigorous non-rigor, it means that you don't have to write out your workings. You just want to apply like intuition that could be converted into steps. Now, what we are not going to do for this is AMGM because it's the maximum value. And if you were to try to use AMGM, you're going to get that it's greater than or equal to, well, that's already the wrong direction because it's greater than or equal to 3, which is useless because I asked you for the maximum. And so this is the kind of question where you realize that the bound is very unusual. But because it's ratio, I can just, without log, let x equals to 1. Right? I can just scale it up and down. And so I want to now maximize this, given that y and z are between 1 and 2 in this order. And so here's the smoothing type argument that we use, but I'm not going to write out details again. Intuition is that if let's say that I've already picked z and now I'm trying to choose y. Y plus z over y, they multiply to z. So assuming I've already picked this value of z, I know that the maximum sum occurs when the two things are further apart. And so therefore, if I want the maximum when they are further apart, it depends on the choice of z, but it means that y takes on an extreme value, either 1 or z. And so I just check both cases. If y equals to 1, it looks like this. If y equals to z, oh, it looks the same, right? Just in a different order. So it looks the same, which means that in both cases, the question is just, all right, how do I make this large? Well, again, they multiply to 1. And so I want them to be further apart. And so if I want them to be further apart, basically, I'm now going to just push z to 2. Because that will make them get the maximum sum as opposed to when I push it to 1. Then of course 1 plus 1 over 1 is 2. That's the minimum by AMGM. Okay, and so therefore your M is 3.5 and your answer is 350. Now every of these that I said here can be justified. Either you can just use like Jensen's like argument. You can talk about concavity of the function. It is even possible just to differentiate. It's also technically possible to just say that it is clear. But however it is, I think the intuition for the fact that the fixed product means that maximum sum occurs when they're further apart, therefore pick an extreme value, is acceptable, and it's also what you should do in round 1. Okay. 16. We say a positive integer n is splitting if it is possible to write 2025 as the sum of n integers which all leave a different remainder when divided by n. Thanks to those of you who pointed out that the original question had a small typo that was caught pretty early on. If I want to write it as a sum of n integers with a different remainder, the key is that it doesn't have to be positive. And therefore, I'm not really concerned about size. It doesn't say they're consecutive integers either, although that would be fine. It doesn't say that. So my only concern is about the different remainders, 0, 1, 2 to n minus 1 mod n, and they sum up to n minus 1 n over 2 mod n, which, depending on n, can be simple or not simple, because remember, this is the number 2025 that you're trying to split up. So if n is odd, that means that n minus 1 over 2 is an integer. It will look like this. But if n is even, this would be n over 2 mod n. Which means that we need to check both cases to see whether 2025 can be in these forms, and if so, when. Okay, so this one's not one of those guesswork ones. This is a more direct one. 2025, we know the factorization very well. And so if n is odd, 0 mod n just means that you're looking for odd factors, which is all of them. So this is the sum of factors. Okay, which if we take the numerical value is as such. If n is even, and I just let n equals to, let's say, 2m. So I want m mod 2m. Well, clearly, m mod 2m just means that your 2025 is divisible by m, but not by 2. Which is essentially the same thing as the first part, except that n is 2 times of that. So this contribution will just be 2 times of 3751, because everything that worked here, if you times 2, will still work. And then now you combine them, it's basically just 3 times of the 3751. Now I'm leaving out a little bit of the details again, however, of the modular arithmetic stuff, because divisible by m and not by 2, you can see that hand waving a little bit, because technically if m is even, then yeah, it doesn't work. If m is odd, then they are co-prime, therefore by the Chinese remainder theorem, you can split them up. You know, all of those stuff, you could write it out more properly. But we can quite clearly see what it means. Okay. 17. So in triangle ABC, D is the full of the altitude, EF are on AC and AB respectively, such that they are concurrent at P. F prime is the reflection of F over AD, and G is the intersection of AD and EF, you have got a bunch of legs. It is, first of all, useful to note that this diagram is rather to scale in the front part. Now, oftentimes when we talk about diagrams being to scale, it is quite important to recognize that the numbers are the least important of the to scale. It is more like angle bisectors, midpoints, let's say cyclic quadrilaterals should look the same as what they say they are. It's okay if the scale of the numbers is not quite there. The reason why that's important is that it therefore suggests that everything that looks true is more likely to be true, and here these look very suspiciously collinear. That is because they are, in fact, collinear. This is actually your Blanchard's theorem, that if you have a triangle and a perpendicular, and you just draw, well, basically what we have here, then these two would be equal. There are at least two well-known proofs of this. One involves extending and using some similar triangles. The other is using some projective geometry. But in any case here, this is to say that because of the fact that f prime is the reflection of f over AD, this is a reflection, and therefore this is actually a straight line. So if you don't know the theorem, you look at the diagram, it seems to scale. Please sort of make educated guesses. That does not mean guess the answer, sometimes guess a property. Of course, this now makes our life a lot easier because it also is true that your angle bisector is useful for the angle bisector theorem. Yeah, Blanchard's theorem is literally just saying that this is an angle bisector. Now you see FG over GE, you're like, oh great, that is actually going to be possible to shift to here. And this can be reflected over to df prime over dE. And that's when you realize that, that's related to area. Because df prime to dE is 1 minus EF prime over dE, and EF prime over dE is just the fraction of the area occupied by this triangle AF prime C of the triangle ADC, which we know the area of the triangle ADC because we are given the lengths 12 and 16. So it's a 3, 4, 5, but not a very important 3, 4, 5 because it's just going to be plugged in. So numerical answer is 95. The flip side, of course, is that this is a useful time to highlight that for SMO Open, there is no fixed syllabus. And if you're talking about the fact that, yeah, it should be a subset of what can be tested in an IMO, well, the IMO has no fixed syllabus either some guidelines, but no syllabus. So we don't know every single theorem. Therefore, two things are true. One is that if you don't seem to know what to do, be willing to make educated guesses of properties, not just answers. And the second is be willing to skip a question, because this looks very innocuous, but the statement of Blanchard's theorem, in order to confirm that this is collinear, is not at all easy to prove if you have not seen it before. Okay. Question 18. This is now a textbook example of your Bayes rule. But you don't really need to know Bayes rule to use Bayes rule. Bayes rule is just like the name of a phenomenon almost, of the fact that the answers to these can come out quite counterintuitive. The question is asking for the probability that someone who tests positive actually has COVID using this test kit, and this test kit, as has been described, seems pretty accurate. So the question is, what's the probability that has COVID given a positive test? Now, it's called Bayes' rule just because of the fact that it has a formula. However, it's more about like describing the phenomenon of conditional probability, which is a definition. Probability, conditional probability specifically, are in A-level H2 statistics. So this is something that can easily come out as part of also probability as an Olympiad topic. Right? They're not going to ask you about normal distributions, but they can ask you about this because this does not need a calculator. So the probability that you have COVID given a positive test is basically the probability, this is conditional probabilities definition, has COVID and a positive test divided by the probability that a random person has a positive test. Now, how do you have COVID and a positive test? Well, there is a 10% chance of having COVID, and if you have COVID, there's a 95% chance that that gets detected. But how do you get a positive test? Well, the positive test could come from the same combination of things. You have COVID and you test positive. But it can also come from don't have COVID and test positive, which is 0.9 chance of not having COVID, and 20% of the time it ends up positive still. Now this is where it's kind of funny, right? So if I were to just clear out all of the the decimals, just multiply by 1,000, you end up with this very peculiar looking thing that says that it's 19/55, which seems very wrong. It is not. This is about 34.5%, so you can do the conversion. Answer is really that 34. It is not a very good test in a way, and yet it is. Okay, so here's the one and only shout out I'll ever do to those of you who are watching this and therefore are math inclined. Bio is actually pretty interesting if you get past the O and A level stuff, because this is in public health, right? And one of the things that happens in epidemiology is a lot of statistics that are actually pretty cool. And if any of you took a bio Olympiad, I think you know there is some data analysis stuff as well. This is an example, but it's also just a math problem. Okay, finally, question 19. Now this is yet another example of it would take quite a while to prove, but we can try anyway to get a highly certain answer. Now, an equilateral triangle of side length n, we can talk about the pattern, which is very simple. The number of triangles in this is just n squared small triangles. That can be found by pattern, that can be found by similar triangles. Whatever it is, the obvious condition is that you need n squared to be a multiple of 6. Which means that n is divisible by 6. And so I will try to get an equilateral triangle of size 6 and see if this is possible. Because if I can do it with size 6, I am quite sure that it should be okay to just tile that repeatedly. Okay. Now this in itself is a bit of a nuisance to draw. I'll do my best. Okay, that's not the worst thing in the world, so we can use that. Now we can try to use this to tile it therefore, right? So you can understand this as sort of like a 2x2 triangle with an extended rhombus out. So if let's say that you are trying to do it, for example, you can say that, okay, this portion is literally that you're allowed to rotate and reflect, right? One of the first things you're going to realize is that, oh, there's actually a very nice way to put two of these together like that. But that is not going to work for this 6x6. And so if you try to cover up those corners, you realize that's also pretty tricky, right? If let's say that you do something like this, you could get this, which is a larger version of itself. But unfortunately, yeah, that last bit doesn't go. Now, when I see something like this, I'm going to immediately think of it as there is some kind of coloring issue, just like our tiling a chessboard with dominoes, right? I'm going to immediately assume that this is a problem. You can't do it with 6x6 because of that reason. And so I am going to just try to quickly do the most classic checkerboard coloring just to see why. For a triangle, this is your checkerboard coloring. It looks like this. So there are 21 of the ones with a dot and 15 without. You can see that all those that we filled in covers 2 or 4. Right? Basically, the ones pointing in one direction are dotted, the ones in the other direction are not. So each spike covers 2 or 4, which means that it is impossible for n equals to 6. Now, if it's impossible for n equals to 6, I am quite confident that by the same logic, it is going to be impossible for any odd one, because n plus 1 over 2 of these dotted ones here, this must be even. And so if it must be even, then n must be a multiple of 4. So therefore, you need n to be a multiple of the LCM, which is 12. Now, what I am not going to do in open round 2 is I am not going to take the time to draw a 12x12 triangle and try to tile it. It can be done. In fact, it is quite similar to what we have down here, just that it's going to take a lot of time to draw that, and my drawing is not that fast or that good, And you certainly shouldn't waste your time on that anyway, because sometimes the tiling is not going to be that obvious. It's just a bit random. I'll leave that for you to try in your own time. But my take is that I will probably just run and say, okay, it probably works. And this is the sum of all possible multiples of 12. Turns out to be correct, and I will let you try to work out how it would tile a 12 by 12 yourself. So as you can see, this somewhat feels a bit unsatisfying. However, this is how the SMO Open has been like in certain years. I think last year you didn't need to go to this extent. 2024's one was not that difficult in terms of having these types of problems, but they have appeared in the past, where if you actually looked and even seen, like, let's say what Limjack did last time, he also would say that, oh, we just guess that something works because we are all human, right? No matter how we have limited time in a round one. This is probably the hardest question, the most long-winded question to write out if you had to do this question because of the drawing. So it could also easily be an open round 2 question. By an open round 1, you would handle it very differently. Okay, I'm not going to be any more long-winded myself either. We will end here, and you'll see part 4 tomorrow, where we go through the last 6 questions. So bye-bye for now. See you then.